Hello and welcome to 19 hours of covering two of the best celestial events of 2020. So, if you've never been here before, this is a slew star party, and tonight it's a shooting star party, I guess. So, tonight we are celebrating what I consider to be the best meteor shower of the year, of the entire year, the Geminids meteor shower. And peculiarly, those of you who kind of check out a lot of slew meteor shower shows, you'll know that we normally do them a lot later. But the peculiar thing about the Geminids is that we can see them before midnight, which is pretty cool. It's pretty cool because it means that we can have an early night tonight. We're going to have an hour and a half of meteor watching now, but then we can catch a little bit of sleep before the biggest celestial event of 2020, the Great South American Total Solar Eclipse. Now, that is tomorrow, Monday. That's 9:30 a.m. Eastern Time, 2:30 p.m. GMT. So that is certainly one not to be missed. This one, what we're seeing here is a huge swathe of the night sky. Now, what you'll notice here, Mike, you can tell us because you know this when you go to one of the world's best observatory sites, which is the Canary Islands. The stars don't twinkle. Why not? So this is a live video feed. It's not a static image. It's a live video feed. Why aren't the stars twinkling like they do when if I go out to my own backyard?
Well, great question. And it is one of those things that really is striking is how, and because of that lack of twinkling, they just appear so close. And it has everything to do with the nature of the atmosphere. And it's the air of, Earth's air that the light from the stars has to pass through. Because what is twinkling in the first place? Well, especially when stars are very close to the horizon, they have to pass through so much of the Earth's atmosphere, just like the setting or rising sun or the setting or rising moon. And as they pass through the Earth's atmosphere, the different layers of the Earth's atmosphere cause there's a beautiful shot of Orion,
Oh
causes
yeah.
the light from the stars to disperse and to separate into their different colors, basically just like a water droplet with a rainbow. And that twinkling, especially with a bright star like Sirius, which is of course is one of the brightest star, is this and was visible I think a moment ago, is magnificent. Oh, did you see
Woohoo!
that? Okay, nailed
It
it.
was worth waiting
There
for. There
we
you
go. I
go.
hope someone was snapping for that one. That was a keeper.
Wow. It
Yeah.
was. Goodness me.
Yeah.
Sorry,
That was,
Mike. That is
yeah.
one of the problems with meteor showers when they are in full flow on one of our star parties, that you'll lose your train of thought because something like that happens. I'm going to ask you about the color of that in a second. So,
Yes.
but carry on. Carry on with
Yeah,
what you were
yeah,
saying.
no, it was it's just like that. There's a movie where there's a squirrel type of a distraction, and but no, the twinkling. So the reason that so the observatories are generally placed at high altitudes, 10,000 feet, let's say,
Mm.
3,000 meters, 4,000 meters, something like that. And the reason for that is just to get above the Earth's atmosphere. And anytime we've been to a high altitude and a mountain, maybe a or there's some sort of a high altitude event, you can look down and you can see how hazy everything is below you. And that's great for astronomy because you don't have to look through all that haze as you're as you're as you're doing your observing. So the that haze is what really causes the twinkling that Paul was asking about. And so what at an observatory, you don't want that. You want everything to be very still and stable as best you can. And that's why observatories tend to be at very high altitudes or even in space where there's zero twinkling
Yeah.
because of course there's no atmosphere.
Now, Mike, the region. Oh, it's just saw a little one down. Oh, and another. That was two
Missed it.
down at the
Missed.
bottom. Oh, and
Oh, I just
another.
saw it. There we go. Yeah, I just saw one at
Wow.
least.
Now,
Huh.
I was just about to say, I was about to orientate us in the sky here, but they've done it for us. Because what we were saying at the beginning is Geminids and all meteor showers, they all appear to come from the same point in the sky, the radiant. And your photo showed that beautifully, your composite photo. So those were two Geminids. in our other shot, the big one. So what we've got here, I can just see at the top of this screen, that is the Orion Nebula. So we've got the constellation of Orion. So that smudgy patch that viewers can see right at the top of the screen is the Great Orion Nebula. It looks absolutely fabulous through SLU's telescopes. And as you say, we've got Sirius there, bright star. And that means that the constellation of Gemini is off up to the right, isn't it?
Yep.
Of it's kind of, when you're looking up at the sky, you see Orion. It's above and to the left of Orion, probably by about the same distance as Orion. Would you say the
Hmm.
same size?
Hmm.
Would you agree with that?
Yeah, it's maybe a little, well, they're about the same size because they're both about 25, 30 degrees in dimension.
Right. Okay. So let's keep our eyes peeled on this. So this is still from La Palma. Um, Come on, I want to see. I want to see another. I want to see another meteor, please. So
I know
okay.
it's
So
one of these
what they
things. It's just like it never gets old because every time you see one of these, it's just an incredible thing. I mean, think about it. What we just saw a minute ago is just one of these little. This was a particle from space. This is
hmm,
from outside of the Earth. This is from sort of beyond it's the solar system, and a little
oh,
bit beyond.
little one
And
there.
this is a part of the universe that just arrived on Earth permanently, and it just that fact alone is just constantly amazing to me.
And that little speck, we've already said, comes off this asteroid 3200 Phaethon. And where does it come from? I mean, this is as old, that little speck that just vaporized in our atmosphere is
Hmm.
as old as our solar system, isn't it, Mike?
Hmm. Sure. Yeah, this
So
is a
where does the asteroid come from?
well. So when you think about this is just such a we have got to be careful, Paul, because we're going to go off on so many different tangents that open up through. But so when you think about the solar system forming from the protoplanetary disk, when you have the sun and the planets and the whole thing collapse into this planar set of masses that are rotating in orbit around the sun. Back in the day, people sort of thought that was the unit, that was the system, the solar system, and then it was embedded in all of the rest of space. And once the Hubble Space Telescope went up and people started realizing that there are, this is the story of this. We're about to go down the story of Pluto and stuff, but the point of it is that there's a sort of an outer disk of material called the Kuiper Belt, and then that's embedded within this giant Oort cloud of material. And it's one of the things that has been so fascinating in recent decades is the discovery of all these objects in the Kuiper Belt and in the Oort cloud. So the Phaethon is as a Kuiper Belt asteroid, and it has a fairly short period, and actually quite a short period. And there's a lot of different comets and asteroids that are like that. And it's as you mentioned, this is a potentially hazardous object in the sense that its path clearly intersects Earth, and so you can imagine if you ran the tape, there'd be some point in the future when Earth and Phaethon are at the same place at the same time. But fortunately for us, it's not. And so we happen to be passing through its debris field when it's conveniently somewhere else. So that's a good thing for us. But um, yeah, it's a really interesting thing when you start thinking about the ways that what we see in the night sky are all connected through these different mechanisms that actually make sense when you understand them. And it's when I was a kid growing up, I saw shooting stars, and I thought, okay, that's kind of odd that a star would shoot as it shot through the atmosphere. But then you realize it's not a star; it's a little piece of dust from an asteroid that's from the Kuiper Belt, and it all just goes together magnificently. So, what a beautiful image of this! You can see, as you say, the stars of Orion. You can see the Great Orion Nebula and some other details in there. So many things to see here.
Yep. So if
And
we
by the way,
tilt
this
our
is
head,
that meteor that we saw a moment ago. It was quite a fortuitous event because the region of the sky we're looking at is not a particularly wide region of the sky. By astronomical standards, it's a very wide
yeah.
field, but if you're standing and looking at the sky, it's a relatively small fraction of it. So the fact that we got that one meteor already through this relatively small fraction is quite good luck.
Exactly, and it is why, so often when we're meteor watching, you'll use a very wide angle to see as much sky as you can, and that's the same doing it visually, which is why you're kind of sitting there and trying to pick out as much of your peripheral vision as possible and not get tunnel focused. Always think that's the worst thing you can do when you're um, meteor watching is if you find yourself focusing on a particular star, like one of the ones in Orion's belt there, you're so focused on that that actually you do get literally tunneled vision, so you do miss a lot of meteors either side. But the meteor that we saw, so this is from the island of Tenerife, so this is from the Institute of Astrophysics of the Canary Islands, which is where SLU's flagship observatory is located, where all of our huge telescopes are. Oh, by the way, we've got a gift card out at the moment. So if you know any budding astronomers or people who are just fascinated by space and want to watch live telescope views, then maybe buy them a gift card for Christmas. But I just want to say to you, Mike, the meteor that we saw, it looked very green to me.
Same.
Why why is it green, and why do we see different meteors with different colors?
This is one of those great things about science is it's so predictable. So the colors come from the ionized air. And what we're actually seeing when we see the colors is the tube of ionized air molecules that are ionized by the kinetic energy of the incoming meteor particle. So you have this tiny grain of sand or this tiny pebble that's coming in with a terrific amount of kinetic energy. And when it reaches the Earth's atmosphere, friction between the incoming pebble or the incoming grain of sand and the air molecules heats everything up. It's just like when you put your hands together and rub them together to keep them warm, that movement, that friction between the palms of your hands generates heat, and that heat is the same thing that happens when the dust particles come into the Earth's atmosphere. And what happens is that heat becomes so intense it literally rips the atoms apart. The oxygen rips the molecules and the atoms apart. So you have the chemical bond between the oxygen gas molecules in the atmosphere and the chemical bond between the nitrogen atoms. And when those are ripped apart, sometimes the electrons within the atoms are excited and can go up to higher states and come down to lower states and give off these characteristic greenish, purplish colors that are associated with the oxygen in the Earth's atmosphere and the nitrogen. And it's that chemical origin of the gas molecules that really gives the colors that you see of the meteors. There may be a small contribution to the colors from the meteor particle itself, but primarily it's the ionized gas that you're actually
And,
seeing that's giving that color.
and
Incandescent.
interestingly, sorry, Mike.
Yeah.
Interestingly, it's the same mechanism which gives color to so many other objects that we see in the SLU
That's right.
telescopes every night. So we've got the Orion. Oh, did you see that one? It just cut in between both of us. That was a
Nope.
lovely one. So that was coming straight down from Orion, which kind of
Ah.
gives us that direction of where the Geminids is. But so we see the reds of emission nebula, the ones that exactly that same process, excited atoms. But we also
Mm-hmm.
get some blues as well, don't we? We get reflection nebulae, which is
Mm-hmm.
just reflected light off young stars. But you were talking. We were saying, talking about green there. We also see green. Oh, there's a nice one going straight across the middle of the screen.
I totally
That
missed
was
that too. I've got
that
to,
was. Oh, you missed out. Come on! I told you, Mike. I told you. Don't look away. Just you've got to stay
oh,
pinned on the screen, which is
I know.
unfortunate for our viewers because it means we're not kind of looking in our cameras. We're looking at our
It's
monitors.
true.
So do excuse the kind of offset eye line. But we see some of these colors in comets as well, don't we? And we covered a couple of comet shows with beautiful green comet comas, the head of the comas.
Yes.
Is that the same process that's going on there?
Exactly the same thing. And there's, well, actually, there you also have, there is a component from carbon-carbon and carbon-nitrogen bond. So there is, due to the nature of the CO2 and the other carbonaceous materials in the comet head. But you're right. I mean, when you look at for example, the aurora borealis, and I know that the from an astronomical point of view, the aurora borealis is a terrible thing because it's a source of light and it gets in the way. And
Light
but from a
pollution. Yeah.
oh,
Oh,
okay,
that's
you
a
saw
good
that
one.
one, definitely. And again,
That was a
that was a
difficult one to
definite Gemini.
miss.
Came straight from the constellation, just like the other one. So from the radiant.
Yeah,
So yeah.
yeah.
Uh, It's I don't know, it's incredible. To me, it always seems like it's kind of a slow burn as it comes through the I don't know if I didn't
Well,
see a smoke trail behind that one, but I have a feeling if we look carefully, we might be able to pick that out
yeah,
after the fact.
I didn't. And what we often see is quite a bright end, don't we? Right at the end of the trail. So it starts off slowly
Sure.
as it's entering, or starts off fainter as it starts to enter the atmosphere and vaporize. But then it gets brighter and brighter and brighter until the thing is totally vaporized, and that quite often happens in quite a little kind of head at the end of it.
Hmm.
But the Geminid meteors, although we're talking about these astonishing velocities of these little specks, something like 70, nearly 80,000 miles an hour, 35 kilometers a second. Geminid meteors, when we see them, are actually a little bit slower than some of the other meteors that we see, and we don't tend to get huge fireballs. That one that we saw earlier, looked very big because we are in this zoomed in view. But the Geminids are often a lot smaller and a lot slower, aren't they, Mike?
Yeah, and I think that's just I can't remember if it's sometimes the Earth is coming into the meteor into the debris field, and there's a relative velocity component. I can't quite remember which way it is for the Geminids, but certainly there's some. I think the Perseids we're going straight in, so we have a head-on collision where both of us are moving at around 35,000 miles an hour or something like that. That adds up to these terrific speeds.
Now, actually, that's an interesting one because when people are watching, observing the meteor shower from their own backyard, one of the problems when you do look towards the radiant, so if you were to look towards the constellation of Gemini tonight and the two bright stars that mark it, the twins, Postra and Calyx, um, Pollux and Castor, sorry, um, they if you look towards there, the meteors that you see in that region are very, very short because they are entering Earth's atmosphere almost directly onto us. The
Mm-hmm.
further away they are, the longer the trains. And we've got a question here actually, Mike, which you can possibly answer. This is from Sonali Deshmukh as well. What is an Earth grazer? So
Ooh,
I've heard this expression before, this Earth grazing meteor. What's one of those, and what causes it?
great question. So, hi, Sonali, a great question. Thanks for asking that. So, an Earth grazer is a meteor that goes through the very upper parts of the Earth's atmosphere and typically takes place when the radiant of the meteor shower is below the horizon or just below the horizon. So the meteors are kind of coming up and they're just kind of grazing the top of the atmosphere. And because they're at such high altitudes, they tend to have a slower rate of heating and incandescence. So they last for a very long time. And they are some of the most spectacular meteors to
Yeah.
see because of those facts. They can go almost across the entire sky. They take a very long time, and they happen at the beginning stages of meteor showers when the radiance below the horizon. Not so likely for tonight with the Geminids because we've been, as you
Mm.
know, the evening begins with the radiant above the horizon. So the Geminids is not typically characterized by a lot of Earth grazers, but certainly, for example, the Perseids in August, it's a great opportunity to see those because the radiant rises over the course of the evening. That's a great
I have
question.
to say, I have to say the Perseids is actually one of my favorite showers, and that's because in the UK, I've got cloud tonight. I can't see the Geminids other than the live feeds here, which is thankfully giving me my
Clear.
my my feast of Geminids for this year. But the Perseus happen, on during the summer when it's weather's normally quite good in the UK. It's comfortable. You can go out, you can watch them. You don't get cold. Well, you still have to wrap up a bit more. But my best ever, I'm going to ask you, I need you to start thinking about your own best meteor shower experience uh, after I tell you mine, Mike. And mine was when I was working at the Canary Islands Observatory, installing a new telescope for SLU. And I was on my last night at the observatory working, which is always an absolutely packed night. And I had my head down. I was desperately wanting to look up and watch the meteor shower. But what kind of brought that whole night alive was people are not allowed, the general public are not allowed at the observatory, but there are some perimeter roads up there, up on the volcano. And it was just thronged with people, holiday makers and people who live on the island of Tenerife, all came up. And there were hundreds, there were probably thousands of people up there. And even though I had my head down in the dome, working hard, I knew exactly the size and the moment of a meteor because this eruption of sound, of whooping, of cheers and wow sounds, just emanated around what is normally the quietest place on Earth at night. The only thing you can normally hear is when the telescopes slew when they move from one target to another. But what about you, Mike? Have you got a meteor shower moment that kind of sticks in your mind? Oh, there was one just on the right-hand side there. That
Oh,
was
I
a quick
think
one.
I saw that one. Yeah,
Yeah.
just up. So it's a we all have these memories of great stories, and I'm sure some of the people watching tonight will have their own experiences yet to develop, yet to occur. But for me, it was very similar. It was back, I think, around 2010 during the Perseid meteor shower. And I backpacked into a Thousand Island Lake in the Ansel Adams Wilderness. It's up in the High Sierra in California. I spent about a week up there, just by myself. Camped, did a lot of stargazing, just enjoyed nature. Backpacking. It's just so many things to enjoy out there. And of course, I timed it. It was one of the new moon Perseid meteor shower weeks, so
Great.
that was very advantageous. And you know, it, when you're in the wilderness, you don't really see that many other people. I mean, occasionally someone will walk by on the trail, or you can see someone moving, but you kind of think you have this whole place to yourself until the night of the meteor shower, when it was very similar as what you just described. There was, I was just, I set my camera up to do an all-night time lapse, and I was just enjoying the evening. And all of a sudden, every time a meteor would go by, you'd hear the whole, like a ring around this lake. You'd hear the whole place kind of erupt in people, cheering and like, "Whoa, did you see that?" And I was like, "Wait a minute, who are all these people? Where are they, coming from?" These voices from the darkness. But it was a very community experience, kind of like what SLU does. Is like we're all right now gathered around the telescopes, looking into the night skies, sharing this. Oh, there was
Oh, there's a
one.
nice one going straight across the middle.
Yeah,
Lovely. Very
yeah.
nice.
So
Very
yeah,
nice.
I think just the community aspect of astronomy is just what's especially great, because the universe can seem
Yeah.
like a cold, empty place, but it really isn't when you think of all the people around the world right now. Oh, there's
And
another one.
another.
Look at that.
Lovely. And we can see that they're all coming from the same direction. And that's exactly what people need to watch for if they're out in their own backyards. But Mike, if we were to see a meteor now, oh, there's another one
Oh,
and another one. That was two within
oh,
a couple of
gee,
seconds. My
Christmas.
goodness.
Yeah.
Um, so we need to see as much of the sky as possible if we can. If we were to see a meteor coming from the top right down to the bottom left, Mike,
Mhm.
is that a Geminid meteor? And if it's not, how do we know?
Well, is not be that would be what we would call a sporadic meteor, and that those just happen, a couple, three times an hour every night you're outside. There's just, I mean, the
Mm,
Earth's moving through space, and there's another one, I think. Um, and so, like Paul said, I mean, the radiant of the Geminid meteor shower is where it says, looks like ORM La Palma, just above that, out of the field of view. And so everything going from top left to lower right is going to be a Geminid, especially if it's a long duration meteor, because those are the ones that are coming out of the radiant. But in contrast, if something was coming from the top right to the lower left, that's at 90 degrees so it's not coming from the radiant of the Geminids, and we would just call that a sporadic. And we'd be very happy to see it. So um, it's that's one of the great things about being outside under dark skies, is that you can pretty reliably see sporadic meteors, like I say, probably 2 or 3 times an hour on pretty much every given night.
So this is one of the best meteor showers of the year. Um, One of the things I mentioned at the top of the show, which you may not have heard about, is the kind of conditions that people should look for. So we
Yeah,
know the Geminids, the radiant rises earlier than most other showers, so we can see them. Normally we recommend people don't stay up late to see a meteor shower. We recommend that they get up early in the hours before dawn. There's another one coming through.
that was another one. Yeah,
When the radiant has risen in the sky. But we've got a very special event tomorrow, Mike, which is part of the contributing factor of why tonight's Geminids
sure.
is such a good shower. The 2020 Geminids is a great shower because there's something missing in our sky at the moment. What is it?
That's what's going to be the moon, of course. And so, what are the, as you say, tomorrow, the moon, well, right now, even as we speak in this moment, the moon is very close. It appears to be very close in the sky as the sun. So, if we were to, and of course, the sun is below the horizon, so the moon is also below the horizon because it's very close. Oh, there's another one. This is a good shower. And so
Yeah.
tomorrow, though, as in the early morning hours, and a very particular, well, anywhere on Earth really, but the moon is going to pass uh, essentially, well, in the path of totality is going to pass exactly right in front of the sun, and so we're going to have a total solar eclipse.
Ooh.
The new moon, there's another
Another.
one,
Yay.
but it's
This is a
this
good
basically
meteor
to your point.
shower. And another.
I know it's like watching popcorn pop in a minute. It's like they're sort like firing off, but it's basically the best conditions are like this, where every 2 or 3 years when we have a new moon, or at least the moon is below the horizon for an appreciable portion of the night, the moonlight doesn't cause the air in the Earth's atmosphere to glow, and because the air is
Oh,
there's another one
lovely one.
is not glowing, we're able to see the stars in their maximum intensity, especially the dimmer stars and the dimmer meteors for that matter.
Yeah. Yeah, exactly. And this is one of the stunning things about the Canary Islands. And just a reminder, so this particular feed, we're looking at a slightly smaller area of the sky. We can see the very familiar constellation of Orion there. We can see Orion's belt kind of going top to bottom. Just below that, you've got Orion's sword, which is actually the Orion's Nebula. We've got the Horsehead Nebula. We got the Flame Nebula, a whole stack of beautiful,
Hmm.
stunning nebulae that look absolutely fabulous through Sloo's telescopes. So this is the island of Tenerife. So this is a place called Izana. It's one of the oldest European, or one of the largest European astronomical observatories. Um, and there's a huge amount of competition actually between the two islands. And if you ask a lot of people where the largest optical telescope is in the world, they'll often say, "Oh, it's Hawaii," or they'll say Chile, the Atacama Desert, or something like that. But actually, the neighboring island of La Palma has the largest optical telescope in the world, called the Grand Can. And where Sloo's telescopes are here in Tenerife, so this is a camera which is about a kilometre, half mile away from the SLU domes, which are operating live at this very moment. So SLU members are controlling those. 8,000 feet, Institute of Astrophysics of the Canary Islands. What Tenerife was known for were huge solar telescopes. So these are very special telescopes used to observe the sun. And if you have a look at the SLU webcams and dome cams, you'll actually see these huge white towers on the horizon. Um, and those are the solar telescopes. But of course, SLU has um, our very own solar telescope, which is operates every weekday. And Mike, we've been I don't know if you've been tracking this recently, but
Hmm.
there's been quite a lot of solar activity over the last couple of weeks. We've seen these enormous active regions and a couple of huge solar flares, which have
Yes.
caused, I think, some aurora, some northern lights visible even down into mid latitudes across the USA and elsewhere, haven't we?
Well, that was the hope for many of us, and you're
Oh,
certainly right
right.
about solar activity. And in fact, I was out with my camera all set up shooting when the uh, when the stuff from one of the coronal mass ejections hit the Earth, you could actually see the uptick in the solar wind speed. But sadly, for whatever reason, it was maybe the combination of the Earth's own magnetic field, the B field, the BZ component in particular. The aurora just didn't happen this time. It was kind of a bit of a fizzle.
Oh,
So
shame.
that's the nature of aurora hunting, though. So we're going to go out the next time it happens. But you're absolutely right. And in fact, we're just beginning to enter into a new phase of sunset of solar activity over the next several
Mm.
years. It's actually, I've seen a couple of scientific papers published that conclude that this could be a particularly good, particularly active solar cycle. So pretty excited about that from an aurora
I read
borealis.
the same thing. It's interesting. The
Yeah.
last 2 weeks, and this is what makes science so fascinating most of the time. 2 weeks ago, there was a paper coming out saying, "Oh, yeah, the next solar cycle, 11-year cycle, oh, it's not going to be very good." But then a week later, a new paper comes out, which is suggesting that actually this is going to be a lot more. Oh, look at that one! Oh, did you see that Geminid
I
then
did.
just coming
I
in from
was.
the top left? Wow.
I'm gonna get.
There's
No.
another squirrel. We should call them squirrels from now on because we
Yeah.
are like
Okay. Saw
oh,
that
and there
one.
was one down in the bottom right as well. So
Yep.
um wow, this is we've done some and a little one that just came straight down. But if you notice, they're all pointing back to that place that Mike and I have been talking about, that
Yep.
radiant in the constellation of Gemini. It's quite easy to spot, isn't it? The constellation of Gemini, Mike. It's you don't see much of the constellation, but the two brightest stars, Castor and Pollux, are
Yeah.
quite easy to spot, aren't they? They're kind of, as I say, to the left and above Orion. Just carry on following Orion over.
Oh, definitely. And then I mean, it's not hard to imagine when you look at the constellation of Gemini, the twins, that there are two, figures that extend downward from there. And it's also fascinating is, I mean, that's right next to Orion, who's another person. And there's just a lot of, if you look at the constellations, at least from a Western interpretation, many of them are, people and animals. And it makes a lot of sense, I guess. But yeah, the Gemini the constellation is pretty easy to find. And the way I would recommend looking for it, of course, is to find the constellation Orion, and then you can find Sirius, which is down below that in Canis Major. It's an enormously bright star. Then you have
Which
Oh,
is, I
there's
think,
another
what we're
one.
saying on the right-hand side, actually,
That's
in
right.
this particular view. That's
Yep, you've got
Sirius
Sirius
there.
there, and then Procyon to the left. And then in fact, I think you can see
Another
Castor and Pollux, can't you? They're straddling the words up there.
quite quite possible. I'd have to check on. I think they're further up than that, aren't they? Oh,
Maybe
a
a little
little
bit.
one coming down. So I mean, basically, if we did do your bit of photometry, sorry, your photographic trickery, and
Hmm.
we aligned all of these images with all of the meteors that we're seeing, it would point directly above
Oh, there's the other
those
one.
two stars. So
Yeah, it would
um,
be a fun project actually to take the feed here because the trickery is really to just you have to kind of rotate the images to account for the Earth's movement, and we've been only watching for a relatively short period of time, so that while there has been some movement, there's not been an enormous amount of it. So this
no.
would be an interesting project to do.
So that came down from what looked like a slightly different direction to me. So I think the one that we just saw there, that kind of came from the top of the middle of the top of the screen down. So I think that was what we call a sporadic meteor,
Mm.
which are you know the normal small flecks of dust and debris that the Earth moves through every night. These tunnels, these streams of debris, Mike, um, they're not very dense at all, are they? And
Sure.
I think the particles are spread out by vast distances, yet we see this number of meters because, of course, the Earth is speeding through the
Hmm.
solar system at an enormous speed. So we're covering quite a lot of space tonight, aren't we?
Yeah, I mean it's just an incredible thing when you think about because on Earth we have our own sense a set or range of human perception, what we see, what we hear, our how fast we move on the freeway and so forth. And the universe has these colossal ranges that are almost impossible to comprehend. And one of the courses I would teach back in the day is called the hidden universe, and it was basically the the universe that we can't perceive, but yet is out there, and it's scales of mass, scales of distance, and scales of energy. And it's so true that there's just so much that are sort of beyond what we could perceive, and that especially when it comes to these speeds, it's just incomprehensible. And you're talking about 80,000 miles an hour, 160,000 miles an hour. I mean, it's just that just I don't have a way to put that into a frame of reference, and that's what's one of the things that is so exciting and challenging about science communication is ways to get those points across in a way that people can understand, including ourselves.
Exactly. But to have such a tiny speck of material generate, these meteors that look
Oh yeah,
so beautiful. So I said at the beginning of the show, Mike, we were oh, another one. This is possibly one of the best or the most numerous meteor showers we've watched. And we are looking at a relatively small area of the sky here. So to be able to see so many like this
right.
is an absolutely cracking night. But let's take a step back. So we talked about, the body, the asteroid that these particles come from. We've spoken about comets, but people get confused, don't they, between meteors, meteoroids, and meteorites. Oh, now
Oh,
there's a
that was a good
sporadic.
one.
Now
Yeah,
that
that
in its own right is is a fabulous sporadic meteor. If you were out tonight, so even if it wasn't the peak of the Geminids and you saw that, it's coming from a totally different direction. So we know it's not a speck of
mhm.
dust from this asteroid Phaethon. Um, it's just a random bit of dust that's maybe come off a comet or another asteroid millennia, probably millions of years ago, and we just happen to have, impacted that as well tonight. So that was a meteor that we saw, Mike. What
Yeah,
are then? Let's if people have joined us late, what's the difference between a meteor, a meteorite, and a meteoroid?
great question. I mean, this it brings to mind another great story. I'm going to try not to get distracted by it, but a meteoroid is the name given to the speck of dust that's in space. So, in
Yeah.
fact, if you think about the debris field left behind by the comets or by the asteroids, you can think of those as meteoroid streams. So, in my
Mm.
ways, they're kind of like embryonic meteors because they're meteors that haven't hatched yet. When a meteoroid encounters the Earth's atmosphere, the Earth, then it becomes a meteor, and we see it. It's the tube of gas we've been talking about. And then if it actually makes it to the ground intact, at least partially intact, then we have a meteorite. And I tell you, these are one of the most incredible things to think about because this is an object from outer space, if you will,
Yeah.
from the universe. And there's this great project that I learned about recently where there's a uh, basically the task of the project is to vacuum up a bunch of basically dirt from the rooftops of buildings in downtown Minneapolis, near where I live, and then by going through a process of magnetic separation, and then examination under at high magnification under a scanning electron microscope, the scientists have been able to actually pick out hundreds of what they call micrometeorites that just
Oh
cascade
yes.
down. And it's just a fascinating thing to think about this constant
Yeah.
barrage of, oh, now that
Wow.
was a gem. That was a good one.
A definite Gemini.
Yeah.
And so,
So,
so
yeah.
Mike, so this meteoroid that you're talking about, which is, can be a grain of sand, the size of a grain of sand, or up to a pea, or a pebble is even bigger. So that has been in existence for at least 4.5 billion years since the formation of our solar system. The meteor that we just saw had a lifespan of
A fraction
half
of a
a
second.
second, a
Yeah. Yeah.
second, probably shorter than that, as you say. So, how do these objects then become meteorites? How does a meteorite exist? Because everything that we're seeing tonight is burning up in the atmosphere, they're vaporizing in the atmosphere, there's nothing left of them. So
Well, that's
where do meteorites come from?
well, they're just big enough to survive. I mean, there's nothing special about them other than their size, how big they are when they start. And as you say, you're right. Very small ones just burn up upon entry, and the dimmer ones that we see are smaller particles. They have the kinetic energy, the incoming kinetic energy is a half mv squared. So m is the mass, and so the kinetic energy just scales linearly with the mass. The bigger is the object, proportionately bigger is the kinetic energy. And there's some interesting physics you can do with the surface to volume ratio in terms of massive objects have a lot of volume and proportionally smaller surface area. And the point being that the larger is the object, the more likely it is to make it to the ground intact. And some meteorites can be, the size of a baseball, sometimes can be the size of an elevator, which is bad. Or I think an elevator is okay. Can't remember the threshold between a large boom in the sky and end of civilization. But they come in all different sizes and flavors. And of course, one of NASA's objectives for years now has been to map out all the potentially hazardous, asteroids that are out there floating around that might cross the Earth's orbit and the Earth's position within that orbit. And things look pretty safe for now, but that's certainly one of the, if you think back to the dino killer, 65 million or so years ago. I mean, it's a hazardous environment, but fortunately, as in terms of human evolution on Earth's evolution within the solar system and the history of the universe, we now live in a time when there aren't that many asteroid collisions with Earth, and it's most likely not a coincidence. It's just if we had evolved before now, we would have been decimated by an impact, and that would have been the end of the story. So, yay for us in 2020 and 20 and beyond.
So, Mike, you're, I wouldn't argue, but a lot of people describe you, as I do, one of the best astrophotographers in the world. You run the Nightscapes Club at SLU. So you have your night. Sorry, I was distracted there by another squirrel.
You probably didn't see that squirrel, did you? Or you did?
Oh, I didn't. Did I miss one? Oh no, I missed one as well because I was
okay.
I
We should
was
keep
looking
a
at a
scorecard.
message.
Okay, there was another one.
How many missed squirrels we get? But you see, how do you know if the other person's kind of saying, if I said, "Oh, did you see that one?" Then you see. Anyway, Mike, you run the Nightscapes. No, you're having me on now. Surely you're having me on now. You run the Nightscapes Club, and you do a weekly Nightscape star party. And so let's go back to your expertise again. You help SLU members with their own DSLR cameras, and DSLR cameras are the main thing I think to use for astrophotography. You can get them. I always have this conversation with you. Go on eBay and you can find a. Whoa, that is the best one of the night. Okay, that is the biggest squirrel of the night for sure. Wow, what a scorch! And another smaller one down at the bottom. Right, you can pick up. So if anybody is wanting, if they've got somebody who's interested in photography and maybe nightscape, taking photographs of the night sky, what should they buy someone, their space enthusiast, for Christmas? Well, you can get secondhand DSLR cameras, but what should they look for, and what kind of lens would they use if they want to do a bit of nightscape photography?
Sure. Well, the good news is almost anything you can get these days will produce great nightscape images, almost including your cell phone. But the key thing, as Paul mentioned, the main thing is a DSLR, digital single lens reflex camera, or a mirrorless camera. These are now capable of producing very high quality images. But that's really it. The key features, the main thing you have to have is the ability to manually focus the camera, because all cameras autofocus don't work at night, and you won't be able to focus on the stars, and it'll be terribly disappointing. So I don't know if anyone really has point and shoot cameras or these bridge cameras, but many of them lack a manual focus capability, and that would be a problem. So but most, as I say, most And even entry-level DSLRs and mirrorless cameras have the ability to set a manual focus capability where you yourself, twist the lens ring to focus the camera or some other mechanism. So the manual focus is one thing, and the other thing is the ability to manually set the exposure. And by that, I mean
Yeah.
the shutter speed, the ISO, the aperture, and that's really about it. I mean, even a standard kit lens that comes with the camera, 18 to 55 millimeter focal length zoom lens is just fine to get started. You can photograph the moon, you can photograph Orion. The winter is a great time to get started with this, but you also need some type of a tripod to support your
Yeah.
camera because you're going to have exposures that are 10 or seconds or 20 seconds, and it's just impossible to hold a camera steady. It's impossible to hold. There's another one. There's another one. So, so DSLR tripod, and then also the last thing would be a headlight that has a red bulb. There's another one. Does someone just replay that? Because that looked awfully familiar.
I think
Paul,
that
I'm
one
getting
was a
suspicious.
replay. Yes, I'm being told by the studio that one is a replay. Yes, we've got
Okay.
replay down in the bottom left-hand corner. Thank
Oh,
you,
there we go.
studio. We did
Yeah.
not notice that word down there. Thank you very much.
Okay.
You see, this is us getting tunnel vision. We're looking for new meteors, and we didn't see the word down at the bottom
Right.
left-hand side. Thank you for that, studio. That was good. So, you know,
Yeah.
what kind of cost are you talking about? Because when you buy a DSLR camera now, you get what's called a kit lens with it, as you mentioned. So you basically get everything you need in that package.
Mhm.
And as you say, I don't know. I doubt whether there are any DSLR cameras for sale at the moment that don't have that ability to set, manual focus and the duration. And it's good to have a good quality um, screen on the. Whoa! Now that wasn't a replay, was
What?
it? But why is that coming up from the other? That's a
Yeah,
sporadic
that was very
coming
much.
up the other
Yeah,
way. Now, if the studio can get us a replay of that and
that was
another
another
one
one.
coming down.
Yeah,
I would
look at that.
love to see a replay of that studio because it looked like we had, first of all, a Geminid coming in from the
Right.
left, but a sporadic meteor coming up from the bottom.
Yeah.
I don't think I've
That's
ever seen something like that, Mike. Have you?
No, that was especially in, for those viewers watching at home as well. Oh, there was another gem. That was
No.
a good, very colorful one.
Brilliant.
Yeah. If you're interested, might I suggest that maybe in the weeks to come you can uh, Google search for meteors from space, and some of the astronauts on the International Space Station have captured a photograph of a meteor from above entering the Earth's atmosphere, and it's quite striking.
Wow.
But yeah,
So,
those are some spectacular. Yeah, so in terms of cost, I would say, realistically, here in the U.S., it would probably be a few hundreds of dollars,
yeah,
really to get started. Um, and borrowing equipment is a great way to go. And sometimes you can rent equipment if you're going on a workshop or something like that. But don't let cost get in the way if you can. I mean, the most important thing is to just get outside and observe the cosmos and appreciate the three dimensionality of space and some of the science and the history behind the objects we're seeing. Why are some called stars blue? Why are some stars bigger than others and brighter than others? What's that fuzzy patch over there on the left in the screen that we're seeing
mm,
that doesn't look like a star? Things like that. And it's all about
yeah,
asking questions and having curiosity
yeah.
and not just accepting things for face value. It's like, well, what's that? And why is that? Why does that look like that? There must be a reason for it. And it's a journey that never ever ends.
It is. And, Mike, you're such a great proponent and teacher of astrophotography. If somebody has already got a DSLR camera and they've never even thought about taking it out at night because they've never even heard of nightscape photography, um, take your camera, get it outside on a
Oh, there is one.
a lovely one just cutting in over on the right hand side, lovely Geminid meteor. Um, what are the basic settings they should use? They should have their lens on quite a wide field view, shouldn't? Oh, we've got a
Okay,
replay coming up, so we keep an eye on that. Oh, look at that coming across,
amazing.
beautiful. Um, basic settings people should try tonight if they've already got a DSLR camera. They want to point it up towards the sky, and there's the replay again. Oh, I
Every
love
time I
when
see
it
that
does
replay, I
that.
kind of jump. I have to
I
say.
know, I know. So, what are the basic settings they should look
Yeah.
for?
All right, so there's kind of a golden combination of ISO, aperture, and shutter speed. For the ISO, I would recommend an ISO of 3200, a shutter speed of 10 seconds or 15 or 10 to 20 seconds. And then the aperture, I would just give it the smallest f number that you have. So as wide open as you can be. So it might be an f-stop of f4.5, f3.5, f2.8, but just not f8 or f11 or f16. Those aren't favorable for night photography. So I'd go for f3.5, f4, f2.8, something like that. And it really depends on where you are. If you're in a bright city location, I think I saw that was another sporadic. If you're in a bright city location, of course, those settings I just described are going to give an image that's much too bright. So you might want to reduce the ISO, reduce the shutter speed. But if you're in a dark location like we are here in La Palma, then I would say certainly the perfect settings here would be an ISO of 6400 to 12,800 with a shutter speed of 10 to 20 seconds and an aperture of f2.8 or 3.5, somewhere in there. And it's very dependent. It's very dependent on your particular location. And if the moon's in the sky, then of course you might want to reduce the ISO, but that should get you started. 3200 ISO, f 3.5, and a 10-second shutter speed or a 20-second shutter speed.
That's great. And then, of course, once you've kind of got to grips with that and see the results, and it's always best to look at the results on your screen inside, probably, so you don't ruin your dark adaptation when your eyes get used to looking at the night sky outside. You can then start with some of the artistry, Mike, which is what you do. So, you start. This is a beautiful view, isn't it, of the night sky we've got here, but we've got very little context. We can see the edge of one of the telescopes down at the bottom. It's a big radio telescope there. But you need some context, don't you, when you're doing nightscape photography? In the same way as you compose any photograph. So what would you recommend, a budding nightscape photographer do after they've got to grips with the basics? Oh,
buy
you
this
plugger,
book.
you. And that's by somebody totally unrelated to you, is it, Mike?
Yeah, no, I've written a couple of books on this type of thing, but the key thing really is when Paul and I talk about nightscape photography, what we're really talking about is landscape photography done at night. So if you think of some really interesting foreground object, like a mountain or a city skyline perhaps, or a lake, or the observatory that you can see down here, coupled with the night sky, what's neat is that gives you kind of a terrestrial framework to appreciate what you're seeing in a sense of scale. If you could see a palm tree here, for example, you have a sense of how big a palm tree is, and you can say, okay, well, that must mean that's what I'm looking at with the night sky. And it's quite a popular it's quite a popular area. And if you want to join us on our Nightscapes Club on SLU each Wednesday afternoon, Wednesday evening, sometimes that was another good one. We have a great community of people from all over the world who join us and contribute and participate. It's a very active group on SLU, and we have a great time sharing our passion for astronomy and for photography and where it lies in between. So, it's really just it's like anything else. It's a journey that just keeps on giving.
It's practice and learning from others. And I have to say, I mean, I don't know how long the Nightscapes Club has been running at SLU now. It's over a year, isn't it, Mike? Is it?
Oh yeah, we started about a year and a half. About a year,
so
almost. I think coming up in 2 years in June or May.
what's been wonderful to watch is groups of SLU members who didn't have a camera, but they joined the club because they loved your work. They loved looking at the work of the photographs of other SLU members. But then a couple of them bought their own cameras. Some of them off eBay, for $100 here and there, and they got out in their own backyards, and they've learned from you over the course of the year and a half, and they are now budding astrophotographers. And what I love about the group is everybody posts their own images and is asking for advice because everybody wants to improve? And I know that you probably are still learning as well, even though you've been doing this kind of photography for, well, more years than you'd probably care to admit.
Most definitely. I mean, it's very much a two-way street. I mean, just this last show, there was someone who had a device for locating. I'll protect their privacy by not mentioning their name, but
Okay.
it was a great device for helping guide your camera during deep sky imaging, and we've had some great discussions of depths of field and lens choice. And but like you say, to me, one of the great things is just the community of people from around the world. I mean, I
Mm,
love traveling and I love interacting with people from globally, and it's just wonderful, especially this year, to have been able to make the connections with people like you say in their own backyard. I mean, we're putting together right now our very first annual poster of nightscapes from around the world. And the connection to SLU is, oh, there was
woo.
another great. I mean, there's just so many interesting objects in the night sky that you can see really only through telescopes like SLUs. And if we were to go and look at the Beehive cluster, like over there on the left, and say, okay, well, that's what that looks like through the SLUs telescope, and this is what it looks like in the sky when I view it with
Yeah.
my unaided eye. It really helps, connect the dots between, telescope viewing of deep sky objects. Was that a
Oh,
replay?
replay,
Oh,
replay. Oh,
that
so
was it.
there's right. So this
That was
is the
it.
replay of
Great
that
job.
section that we wanted. Thank you very much, Studio,
Yeah.
for doing this.
Well
So
done.
let's take another look at this, Mike.
Let's do that.
Here it comes. So there's Geminid. There was another Geminid
Wow.
at the top, and that is a
Yeah.
sporadic. That is no aberration. That is, I don't think
That
I've
was a real
ever
deal.
seen
Yep.
that. I mean, and they were large meteors as well. They were not kind of tiny little meteors, but for them to almost go in opposite directions, what a lovely thing to see. There's one there, one at the top, and there's the sporadic
Yeah,
coming
that's
from the
incredible.
opposite direction. You know,
Talk
the
about
fact
an
that it's
active black
actually
hole.
heading in totally the opposite direction towards the radiant. So that's a special one for sure. So
Oh, yeah,
uh,
that
it's amazing,
yeah,
isn't it?
those are
Because
like
there's
perfectly parallel.
yeah, yeah.
Yeah.
At first, I thought, it must be some kind of aberration in the telescope, but they're not identical. So there's no reflection thing going on or some strange thing. They were
Nope.
independent meters. Here we are back in Tenerife, which is probably a good place for us to start finishing up here, Mike. So this is not the kind of view that SLU members watch every night. You were talking about our community. We have this global community of members all sharing the same sky and all controlling our telescopes at the Canary Islands Observatory. That's SLU's flagship observatory at the Institute of Astrophysics of the Canary Islands. But we've also got that shows us great views of the Northern Hemisphere skies. But we also have our Chile Observatory, which is also online right at this very moment, I do believe. I'm not going to look because I'm going to miss a meteor. But we can also see the Southern Hemisphere gems. And Mike, I don't know if you've got this on your phone, but I have a little kind of app thing on my phone that shows me photographs or images that I took a year ago. And
Mhm.
2 nights ago, um, up popped. This is what I was doing this time last year. And it was my last night down at our Chile Observatory at the Catholic University Observatory outside of Santiago. Another one there. Look,
Another
they're
one.
coming thick and
Yep.
fast still. And it was my last night of a 3-week visit down there where I installed a new telescope, the
I
Chile
remember
2
that.
telescope. Yeah, it's a 17-inch telescope. That's over 400 millimeters in diameter. It's revolutionized what SLU members can do imaging the southern hemisphere, hasn't it? Yeah, I know you've been
Absolutely
using a
incredible. I
lot of
mean,
those shots.
absolutely.
Yeah.
Yeah, it looks like Hubble
What
Space Telescope, which is honestly, it's just incredible how the detail and the resolution and the dynamic range are just spectacular.
Yeah, it's an absolutely smashing setup down there. Now, Mike, we've got while we carry on watching for some last meteors here, we've got some fairly special events coming up here at SLU, which are going to run a lot smoother than the beginning of this one did tonight. So apologies to viewers, but if you've stuck it out this far, you have been rewarded with a whole host of Geminid meteors. But tomorrow we're coming back, and another one. Goodness me. I think
Oh
this
yeah.
is the most number of meteors we've seen during a SLU meteor shower star party. I think it's
Yeah.
absolutely fabulous and it's really indicative. If people can see this in their own backyards, they're in for because you'll see far more when you're looking with your own eyes. You can see more of the sky than we're looking at here. But tomorrow, Mike, we've got what is to me the best celestial event of the year. What are we going to be watching together tomorrow?
Well, I'm really looking forward to this. This is a real honor to be part of this one, but this is the total solar eclipse that's going to take place in South America. And, I know I know at least one person who is traveling down there to observe it in themselves. But this is just one of those events that's not to be missed.
Yeah.
And it's just one of those weird coincidences of nature that as the moon passes directly in front of the sun, they're exactly the same, at least for the middle part of this one, they're exactly the same diameter. And the effects that are produced by that are just phenomenal. And I'll leave it at that. But yeah, it's one of
Yeah.
those things not to be missed,
Yep.
for
So
sure.
that is tomorrow. That's 2:30 p.m. GMT, which is 9:30 a.m. Eastern time. And then, you know, there's a fascinating diagram actually, Mike, that we're going to show tomorrow
Hmm.
about where the path of totality is going, because it's going right over the southern tip of Chile and Argentina, which is a very small amount of land mass for. So this is where you can see the total solar eclipse from. But you see this diagram that we've got, and the Earth is really tilted up, and that's because we're only a few days, a week away actually from the December solstice. So December solstice is when the Earth's southern hemisphere is tilted most towards the sun, and another meteor there. So we've got a show coming up. This is going to be a fascinating show. I'm hoping you're going to commit to coming to this one, to at least view it, Mike. It's the still sun celebrating the solstice, and we're celebrating the moment of solstice because a lot of people think solstice is a day, but there's actually a moment
Oh, it's a
of
moment. Yeah.
solstice when the sun is at a standstill in the sky. That one starts at 5:30 a.m. your time, or Eastern time. Are you going to be up and around for that one?
I might be, yeah. I might have a couple of
Okay.
kids in the background, but
Okay.
we can give
So
it a
what we're
try.
doing there, we're having a very special show for that one. We're going to have live views from the Canary Islands SLU solar telescope. So hopefully we'll see loads of that solar
Oh, that'd
activity
be
that's
great.
been visible at the moment. But we're going to end that one off as well with a special yoga session with Caroline Kinsolving, who's an actress, Shakespearean actress, and yogi. And she's going to take us through a lovely little relaxing yoga session at the end of that
That's
star party, which is
fantastic.
going to be
Okay, yes,
really
I'll
quite
be there
cool.
for that. Now,
Okay,
now,
so
now I'm in. I'm in.
I suspect I might get into a position that I might not be able to extricate myself from, which is going to be really important because you're then joining us for a show later on that day, which is at 2 p.m. Eastern, that's 7 p.m. GMT, and it's the Great Conjunction. Now, I am really looking forward to this. It's historic. It's the closest, we'll tell people in a minute what a great conjunction is, but it's the closest one since think 1623. They only happen every 20 years. So SLU's been going for 17 years. We've never seen a great conjunction.
That's
Mike,
fantastic.
tell us what a great conjunction is, because I know that you've been photographing this already. And in fact, the SLU telescopes have been photographing it every night. So what is the great conjunction that we're covering on Monday, the 21st of December?
Well, it is truly a historic event, and so the planets Saturn and Jupiter, if you haven't seen this already, appear to be getting very close in the early evening sky. And this just happens because they're moving in their orbits at different speeds, and so and their orbits are in the same plane, so it's like two cars that are lapping each other on a race car track. And on that night, and in fact, if you can go out tonight, I've been going out for the last couple of weeks, and it's
Mm.
certainly worth seeing. But on the night of the 21st, on the solstice, coincidentally, they're going to be so close in the night sky, it may be impossible with your unaided eye to differentiate them. And they're just going to be this one super bright spot of light.
Mm.
And through a telescope, I mean, Saturn and Jupiter are two of the top images top objects to observe through a
Objects.
telescope, and to
Yeah,
have them in a single field of view, the rings and the moons and the bands
yeah.
and I mean,
We we
it's an event that not to be missed.
Yeah, we saw tonight. I mean, Sloo's telescopes have a variety of fields of view, as Mike says, and a field of view is really the amount of sky that that particular telescope can look at. Oh, look, well done. Thank you very much, studio. So what we've got here is this little diagram of, you can see there, November 26th, they were quite a long way apart in the sky, getting closer and closer and closer. And what's actually happening is Jupiter is catching up with Saturn. They're both kind of moving in the night sky. But Jupiter, because it's closer to us than Saturn, its orbit is smaller. It's catching up with Saturn, and actually he's going to pass it after the 21st. But all of the SLU telescopes have different fields of view, the amount of sky that we can see. And what we're doing at the moment is one of the telescopes, the Canary 3 Deep Sky Telescope, has a very large field of view. And all this week, we're able to see both Jupiter and its 4 Galilean moons spread out on either side. We're seeing Saturn with 2 of its moons getting closer and closer each evening. Then at the weekend, they come within the field of view of some of our giant telescopes, the half-meter telescope, the Canary 2 telescope, and we're going to see them in unprecedented detail there.
Wow.
But then on Sunday, Monday, and Tuesday, we're going to see them in glorious close-up because they come within the small field of view of what we call the Canary 4 solar system telescope. So this telescope is designed to capture the planets and small objects like planetary nebulae and stars, just small objects basically. And Jupiter and Saturn are getting so close together that they even fit within this tiny, tiny field of view. And Mike, I think this is kind of perfectly timed really for the holiday season, because we'll talk about this on the show. But there are some thoughts that the Star of Bethlehem was thought to be a great conjunction, isn't that?
Actually, absolutely. And certainly when you see, oh, there was another one.
Woohoo! That's
That
a
was a
good one.
squirrel. Absolutely. And so it'll be great to see this actually take place and to just consider all the different implications of the positions of the satellites, because it's going to be just a
Yeah.
spectacular event in the sky. And for those planning to view it, I mean, it's only going to happen, just to plan ahead, within a few minutes of sunset on the 21st. So
Yeah.
it's certainly not an event to go out at 8 or 9 o'clock at night and hope to see it, because they will have set below the western horizon. So you want to, but the good thing about this is they're so bright that you can see them even from within most cities. And so
Yeah.
this is not a difficult object to see. You just have to have clear skies right after sunset, or within an hour or so
Yeah.
after sunset.
Yeah, exactly. And even we're going to be limited even on our star party length. We've only got them for 30 minutes before they start setting
Right.
below the horizon. But we have also got, by the way, on the Great South American Total Solar Eclipse Star Party tomorrow, Monday, we've got some rather special news for you. Um, there's only one total solar eclipse in 2021, which is in December. It's incredibly difficult to see because the path of totality, you have to be down close to Antarctica to see it.
Hmm.
But tomorrow we've got some details of how anyone can join the SLU Total Solar Eclipse Antarctica expedition, a 20-day polar
Wow.
odyssey down there. All right, there, that's the first Mike's heard of that one. You see, it's an absolute
Wow.
exclusive. Um, but SLU members can join us on a SLU expedition. We did something similar a few years ago for the transcontinental USA eclipse, and it was just wonderful. As Mike said, having a community together, having a virtual community is absolutely wonderful, but having that odd occasion when you can all get together in person to witness one of these absolutely extraordinary and life changing for a lot of people celestial events, it's going to be It's going to be a good one. So I'll talk
That
to you
sounds
about that, Mike,
that's
maybe
amazing.
maybe tomorrow. But it's going to be an absolutely fabulous trip. So anyway, Mike, I think we should round up tonight. Have you got anything you'd like to say to viewers before we round up?
No, I mean it is. Thanks again for joining us, and especially for your patience at the outset. But this is really one of
Yep.
those great events that we're all in this together, and just if you can share this with somebody who might not have had a chance or thought to get outside and enjoy it, it's such a rewarding thing, and it's
Mm,
certainly the sort of thing that sometimes people don't know what they don't know, and
mm,
being that person in someone else's life where you can introduce them to a new outlet through SLU or through just going outside yourself and looking. It's a lifelong journey, and it just never ever ends. As you can see from
yeah.
tonight, I mean, Paul and I just touched on a few things that we're gonna, I'm sure, just continue to carry on discussing. But no, thanks so much for
Excellent.
having me on. It's always a pleasure to be part of these discussions, Paul. And
Well, thank you.
congratulations on a wonderful night.
Well, thank you very much, Mike, and thank you for managing to come on a little bit earlier and bailing me out. I was juggling a little bit there, but viewers, this is a great test for tomorrow in 14 hours time or thereabouts, 9:30 a.m. Eastern time, 14:30 UTC. That's 2:30 p.m. GMT. Monday, the best celestial event of 2020, the Great South. Oh, and that's
Saw
a
that.
lovely little one to finish us off on the Great South American Total Solar Eclipse. There is no other astronomical spectacle that comes anywhere close to totality when our moon totally obscures the sun. Now, I've got one last little thing to say to you all. If you have enjoyed this, or you know somebody else who would enjoy this, then don't forget, you can join SLU, but you can also hop over to Amazon and you can buy a gift card membership to SLU, and that allows your loved one to control SLU's mighty telescopes. And we don't do many shows, many public shows, where we show the live views from SLU's telescopes, but you see things like Omega Centauri, that lovely globular cluster, the Tarantula Nebula in the Chile telescopes, or the Orion Nebula in the Canary Islands telescopes. I mean, they still, after 17 years, the live views of those objects make my jaw drop. So if you have got somebody out there who's either just a budding enthusiast, just loves the awe and wonder of looking up at the night sky, then this is a great gift for Christmas. I know that's a bit of a plug, but we want to grow the community because it's an absolutely fabulous place to be, with lots of things to do, including Dr. Mike Shaw's Nightscape Club if you want to learn how to do a bit of astrophotography yourself as well. So, Mike, thank you very much for joining us tonight. Thank you very much, everybody at the studio, for helping us. Thank you so much to Skylive TV, the Institute of Astrophysics at the Canary Islands, for these wonderful feeds. I mean, I don't think we've ever seen quite as many meteors in a single show, and we have seen some absolute corkers tonight. So thanks to them, and thank you to all of you for watching. We will hopefully see you tomorrow for our total solar eclipse coverage. Good night for now.
Good night. Thank you, Paul.